So we're talking about the mean value theorem here, and we've got some problems in this worksheet, but I just want to show kind of a graphic representation of how this works, because you can do these anytime it does apply. And this was our function. This was the example on the worksheet I gave you. And we'll get that out here just so we're on the same page, literally. I don't know if you can see this. So this is the glare here, but anyway, this is the worksheet, and we were using this example, x squared minus 2x plus 1. So if you read through this, we kind of show that that is continuous and differentiable, or CC2 as we say, continuous on the closed interval and differentiable on the open interval. So we went through the process of finding the value of c, where f prime of c equals the average rate of change over that interval. So that's all right on the worksheet, so you can take a look at that. But what I want to do is kind of graph everything so we can kind of see how it looks, just to verify it graphically. So here's my y equals x squared minus 2x plus 1. This is the derivative. And then we found that the c was going to be 2, so we know that f prime of 2 was actually 2. And that's the slope. This is the average rate of change, so we showed that those are going to be equal. That's the value of c for that value of c. That's how we found it. So the secant line, if we want to find the equation of the secant line, we know the slope of the secant line and the tangent line will be the same. That's the whole point. Okay, the average rate of change is equal to the instantaneous rate of change. Average rate of change, instantaneous rate of change. Average rate of change, instantaneous rate of change. All right, so we know that those are equal, so I just wanted to graph these. So we want to find a line. Now the secant line goes through both these points, so I could use either point. So I just used, or either x value. They both go through these points, 1 something and 3 something, so I could do either one of these. So I took 1, and if I put 1 in here, I get 1 minus 2 plus 1 is 0, so the secant line goes to the point 1, 0. All right, I could put 3 in here and also go through that point. All right, but I just picked that point. Now I know the tangent line is going to go through the point 2, just that point, x equals 2. So if I put this back in this equation, 2 squared is 4 minus 4 plus 1 is just 1. So this is the point that the tangent line goes through. This is actually the point of tangency. And I get my equations of the two lines. This is the equation of the secant line, y minus y1 equals m times x minus x1. And if I just solve for y equals 2x minus 2, so that's the secant line. And this is the tangent line. Y minus 1 equals m, same slope, x minus 2. So I simplify, I solve for y. So these are my equations. So this is how I graphed it. So let's see if it does indeed look like what we would think it looks like. So this is how you'll put it into your calculator. Now I use this window because I started with a zoom 4, but it didn't give me exactly what I wanted. So I'll take a look at this. So that's how I put the problems in. Okay, so again, this is our function, this is our secant line, this is our tangent line. And if you go to zoom 4, there's our function, there's the secant line, and there's the tangent line. And you can see it a little bit better if you go back to the window and change the y to -1 and down to 6. And I think you're going to be able to see a little bit better. And again, there's our function. And here's our secant line. It's going through the point 1. And there's the tangent line. And this is 1, and this is 3, and there's 2. And you can see that's over there at x equals 2. That was that point of tangency where the tangent line is parallel to the secant line, or the instantaneous rate of change is equal to the average rate of change. If you want to double check that, you could trace it. And here's my x values. And I can see how x goes over to 2, and there you can see it. There's the point of tangency, and at that point, the instantaneous rate of change is the same as the average rate of change over that interval 1 to 3. So that's a good illustration of how that works graphically. Okay? All right, so let's take a look at